Okay, so the next unit we're going to talk about is chapters 7 and 8. And chapters 7 and 8 deal with chemical bonding, both ionic and covalent, and molecular structures. Molecular structures, we're going to start to take a look at the shapes of molecules, kind of how they form in space, how the atoms of the respective atoms of the molecule kind of gets away from each other, what the geometry is. Don't be nervous about the word geometry. We're not getting into heavy-duty mathematics, but certainly we're going to take a look at angles and how the shape itself relates to what things are getting together. So that's chapter 7 and 8. Let's go right ahead to it. We're going to talk, let me just review a little bit with ionic and covalent bonds. We know that an ionic bond is a loss and, I should say and or gain of an electron. Should be kind of and. So an example is like sodium and chlorine getting together. When you have sodium, of course, sodium with its plus charge means it's lost one electron. Remember, a positive charge is a loss of an electron. Why? Because you have more protons and electrons in the atom. Chlorine forms a 1 minus charge, which is a gain of an electron. Notice that they go together, you know, like peanut butter and jelly, they go together really well. If one wants to lose an electron and one wants to gain an electron, then it makes so perfect sense that they can form NaCl. Just needs one of each, okay? You can take a look at it with the electron configurations as well. Let me just look at chlorine real quickly. Chlorine's electron configuration, 1s, 2s, 2p, 3s, 3p. All the s's have 1, the p's have 3. Okay, of course, all of these bottom ones would be full. Chlorine has 17 electrons. And notice that when we get to the 17th, I'm done right there. So it ends 3p5, which means there's one available. That's why it wants to gain one electron. If chlorine gains one electron, then it has a full set of valence electrons, very happy, acting like a noble gas, and it's very, very stable. So that's kind of why and how these ionic bonds get together. All right. Obviously, the next type of bond is a covalent bond. Covalent bonds are sharing of an electron pair. A really simple example is chlorine, Cl2. Notice that chlorine has a -1 charge. Obviously, if there are two of them, as there are in Cl2, they both have negative charges, which means they both want to gain electrons. If they both want to gain electrons, they're not going to get together in an ionic bond, which would be a plus and minus, and a positive and negative, a loss and a gain. So this molecule gets together with a covalent bond. And how that looks is, let's say I have this blue chlorine. We're going to see these dots in just a moment. But it has 7 valence electrons, and I'll describe that shortly, but 7 valence electrons. Both of them have 7. And so therefore, the ones that are all doubled up already aren't available for bonding. But these two single ones are. And when they bond, when the blue one gets shared to the red one, then the red now has 2, 4, 6, and 8 around it. And the blue one has 2, 4, 6, and because it's sharing, it has both the blue and the red, it also has 8. So notice 8 is a full set of valence electrons, very stable, and therefore covalent bonding sharing is happening. I want to very quickly talk a little bit about some covalent ionic stuff before we move on. I want you all to remember the difference between something like MgCl2 versus PCl2, magnesium getting together with chlorine. This one would simply be called magnesium chloride. This is a ionically bonded substance because you have your magnesium, which is a 2+, chlorine, which is a 1-. Of course, the least common multiple in this case is 2. And so we need only 1 magnesium, we need 2 chlorines, hence MgCl2. Notice no prefixes because it's ionic, okay? Versus PCl2. PCl2 would be called phosphorus dichloride. Notice the prefix. And again, the reason is because if we look at it, phosphorus forms a 3- charge, chlorine forms a 1-. This is not ionic bonding, okay? So it has nothing to do with the charges. Has nothing to do with charges or loss / gain of electrons, but rather sharing of electrons. Electrons. And so we do need the prefixes. And of course, that's a covalent bond. All right, good to see and review a little bit as well. The last thing I want to kind of review real quickly before I continue to move on with this unit is our polyatomic ions. It's really good to see those. We have NH4, OH-, C2H3O2 with a minus charge, NO3-, SO4 2-, CO3 2-, and PO4 3-. Just the 7 polyatomics that I've given you and asked you to learn. Ammonium, hopefully as I was writing them, you were remembering them. Hydroxide, acetate, nitrate, sulfate, carbonate, and phosphate. Again, polyatomic ions that are very important for looking at ionic bonds. All right, so we'll stop right there and move on to the next one.